Now we can check out the power flow in a vehicle. This is the schematic diagram of a normal rear-wheel drive car. That's the engine which manufactures the power. So here we have chemical energy getting converted into mechanical energy, and via the crankshaft we are supplying this power to the gearbox. In the gearbox we are able to manipulate the torque, that is, we can either step up or step down the torque produced. From the gearbox, the torque is sent to the differential via the propeller shaft. The rear differential splits the torque to the two individual wheels at the rear, which is the rear right wheel and the rear left wheel, and the vehicle propels forward. This is what happens when it comes to power flow in the rear wheel drive vehicle. Let's take an example. Here, what we are calculating is the available torque at each wheel. Considering that 250 Nm of torque is produced by the engine, and let's say that the gearbox is engaged in the first gear, and let's take the first gear ratio as 4:1. We are taking numbers like 250 and 4 just to make the calculations look simple. When the first gear ratio is 4:1, 250 Nm torque which the engine produces gets multiplied by 4. This way we have 1000 Nm torque which is going towards the rear from the gearbox. Considering the final drive of the axle to be 3:1, you will have another multiplication of 3 to this torque. This will make the torque value shoot up 3 times to 3000 Nm. When the vehicle is moving straight, the differential would split it equally and you will have 1500 Nm at each wheel. So this is the torque available at each wheel when the engine produces 250 Nm of torque and the gearbox is set at the first gear.